Good morning, mathematicians. And we're back. Part 4 of the SAGA. Yep. We're going to switch over to Milne's notes today. Officially. And we're back. And maybe I'll be less confused, or maybe I'll be more confused. Milne definitely has great notes, but I also remember trying to read some of them when I was an undergrad, and I was confused then about some things. Maybe I'll be less confused now. Yeah, so let's jump over cohomology groups. Good morning, Ken. Good morning. Okay, so we can breeze past the things we've already seen. Okay. So let's see what he calls induction. Induction is a set of maps from G to M. Okay. So induction here is basically what we normally think of as induction of representations. And that will be right adjoint to restriction. Awesome. Yes, these are Milne's notes, indeed. You can ask a quick finite group question. But you should never tell me that it's quick. You may think it's quick. Just say, can I ask a finite group question? We both know it's impossible to determine how long a question really is. I just may not answer it. But I might. You should ask. You should ask it. Yeah. Okay, so just some more theorems about induction, but proved in a little more detail. We may come back to these. Injective modules. Least favorite finite group. Oh. I don't know, probably just something like really big and complicated. But like not the monster group, because obviously that's cool. You know, something big and complicated without much reward. A group with 175 elements acts on a set with 9 elements. This isn't going to be quick. Show that there's a non-trivial in G, which fixes everything. I see. Maybe it will be. What's the fixed point formula? So, right. So, what's our class formula? We've got X is the fixed points plus the indices of the stabilizers for the non-trivial orbits. The chat log is crazy. The blood moon affected my connection. Blood moon? The moon does look very bloody over here. Because of all the smoke from forest fires. Show the kernel of the induced homomorphism is non-trivial, yeah. Well, what we have, so what is the set has 9 elements, right? Set has 9 elements. And the group has order 175, which is going to be 8 times 25. So 2352, right? It was a lunar eclipse yesterday. Oh. Or a couple days or weeks back. Wow. I don't think I'm getting cursed from a couple weeks back. Unless it took a few days for the gods to realize I didn't make the necessary sacrifices. Anywho, so what does that mean? That means that in order for these equations to balance out, what are the possible indices here? Well, the indices can't be 1 because that's only accounted for by these guys. So the indices could be 2, 4, 5, or 8. The indices can only be these numbers, right? Because they've got to be divisors of this, and certainly, this is at least 0. So it's going to be these. You can show the possible stabilizers, have those sizes. Yeah. Well, here's how I would think about it. So we look at this equation, right? What are the possibilities for this to be 0? Well, suppose we had one of the groups was 8, or one of the indices was 8. Well, then that would force this number to be 1, right? Definitely if we have a thing of order 8, then we have 1 there. Okay, what if one of these guys were 5? So we have 9 equals, x plus 5. Well, this x would, again, have to be built out of these numbers. But we could have a 4 and a 5. We could have a 4 and a 5. Oh, I see. Hence the intersecting of the... right, so you're trying to rule out those sizes of stabilizers. So it suffices to show the 25 and 35 element stabilizers intersect in a subgroup of order 5. Yeah, I wonder if you could do some element counting tricks. CELO stuff and element counting tricks and prove that they have to intersect. I don't know. Who the traditional math muse is? The poets of Calliope. Who's the OG math muse? I don't know. War? Well, I don't know, I'm torn. Part of me wants to keep going down this track, but I have officially titled this series the Galois Cohomology Saga. So we might have to go back to the Galois Cohomology Saga. I think we're going to go back to Galois Cohomology, Ken. I'm sorry. But maybe this is a mistake. Maybe my viewers are hating this. I don't know. Oh, we're gonna see we have the proof that G modules has enough injectives. Okay, so abelian groups has enough injectives is proved in A4. Good morning, Arad. Now let M be a G module, and look at the underlying abelian group. That can get injected into an abelian group. And then if we apply this functor, we have an inclusion. Sure. We have an injective homomorphism, so we gotta show this is injective, but then we use, nice, that's slick. That's a cool proof. Well, yeah. Oh, Arad, yeah, I guess you haven't been around for a couple days, so, this is, well, I mean, we're inevitably going to talk about class field theory, I guess, but the original point was to just do Galois cohomology, which, okay, to what extent can you, and do you want to separate these things? But we'd found a random PDF on Galois cohomology, and I decided to make a saga of me going through it. But then it turned out to kind of not be the best written. So we decided to switch over to Milne, and I'm just jumping ahead to the Galois cohomology parts. Yeah, we'll probably get into some actual number theory at some point. Okay, so injective resolution stuff, group cohomology stuff, which we've already seen in the other note. Yeah. Oh, you think you only missed yesterday? Well, you missed one day, and it feels like I haven't seen you in forever. That's relativity, baby. Shapiro's lemma. Right. This is, I think, where we left things off in the other document. So we've got a G module, Z regarded as a G module. Yes. See, so it's actually explained in here. Although I figured it out from the other document. This Hom set is isomorphic to the fixed points. Absolutely. Great. So Shapiro's lemma, fix a subgroup, and for every H module, there's a canonical isomorphism. Hey, Thomas, how's it going? There's a canonical isomorphism from the HR from cohomology valued in the induced thing into cohomology in here. The H cohomology, there we go. Interesting. Interesting. So, you stumbled upon a fan of mine in your algebraic topology lecture abroad, really? Wow. Cool. I didn't realize having just under 7K subs, I was big enough for those sort of things to happen. You believe that Shapiro's lemma can be stated as restriction, induction, adjunction, being a Quillen pair. Oh. Given to closed model categories, a Quillen adjunction is a pair of adjoint functors, preserving fibrations and trivial cofibrations. So, oh, that makes sense. Yeah, my Who Gives a Sheaf series is fairly famous. True. In math world, I guess. I really should make more of those videos. Is the homology saga going to be numbered part 4321? Absolutely. Although, of course, that's going to take some planning to know when it's supposed to end. Absolutely, though. Yeah. Yeah. My Who Gives a Sheaf series definitely... there's like 30,000 views on the first video. And I think a couple hundred on the most recent one. I think I need to do a new video on it soon. Locally ring spaces. Where's the most recent one? Okay, 524. That's not bad. 4 months ago. Yeah, I really got to do more. You never really grokked Quillen adjunction. Besides the fact it's supposedly correct notion in model categories. Yeah. Well, I mean, yeah, I'm not a pro at model categories, but okay. Fibrations and cofibrations are things that we like, and so, okay, you have an adjoint pair of functors, a thing that we like, and we ask that it preserves a more extra thing. Cool. The first part will always have the most, yeah. Proofs are trash one did do quite well as well. That is true. And that was due to the thumbnail, yeah. Actually, I think it was Proofs are trash 3 was the one that did really, really well. I think that was the one that did really well because of the thumbnail. Wow. Wow, Extra. I feel so popular. Also, yeah, Arad, I guess you missed it. I got my first live. Someone gave me money in chat. Someone gave me a whopping $25. That's getting close to new textbook kind of money. So it's a new era for the channel. Not sure if there's good intuition for it. You should be able to view adjunctions of infinity categories as correspondences. What does correspondences mean? I've seen this before, and I think I've seen some papers where they have an appendix about like the category of correspondences in this like Langland's categorical Langland stuff. But yeah, I guess the point is what it induces, like an adjunction. It's like a pair of, I'm guessing in the abelian category case, yeah, this is a pair of functors that like induces adjoint functors on the derived level. In an alternate universe, we would have more of his notes. Well, he probably, his ideas come out of thin air because he probably did access an alternate universe. And that's where he's getting his notes from. Okay, let's go through the proof of Shapiro's lemma. We should do some work, guys. Okay, so the isomorphism is the composite. Wait for r equals 0. Nice. Look at this. Even nicely cited here. Okay. Yeah, so this makes sense. So we have NH, right? The fixed points is isomorphic to this Hom set. Then we're using the adjunction. And then that's isomorphic to this Hom set. Oh, right. And then that is the r equals 0 case. Okay. When you have to advertise it, you always explain via this Siegel subdivision and Waldhausen, because that's simpler, but that came after Quillen. Yeah. Yeah, it is interesting. There's just a lot of things in math that we have great post hoc descriptions for why things are that way, but it's just sort of mysterious how they first got there. Okay, then we choose an injective resolution of n, and we induce to obtain an injective resolution here. And it preserves injectives because we have an exact functor. So that means that this is isomorphic to... now hang on a second. This is equal to this. The G invariant all of Quillen's working notebooks are published as PDFs, huh? Okay, but now I'm being dense. Why do we get the G fixed points? Why do we get the G fixed points? Wait, what does this even say? Keep the mystery alive is a great excuse to skip hard proofs. Yes, I'm gonna remember that. Oh, this just says it's... Oh, I understand what's here. This just says it's the homology of the complex. Okay, hang on. I'm being really slow this morning. And what morning am I not? Am I right? Right. So we're trying to compute this. What did we do? We took this injective resolution, and that gave us the injective resolution here. And the claim is that this should just be the cohomology of the G fixed points of this complex. Right? That's what he's saying. Why is it the G fixed points of this complex? Hello, Femnal. Galois cohomology of an injective resolution is the chain cohomology of the levelized fixed points. But why? So, okay, let me write it as, I want to convince myself that this is true. So I plus 1, call this D, I guess. Di plus 1. So, I mean, basically I want to see that the kernel of di fix, I mean, here's how we build it. We have the inclusion into here, and then we compose with the quotient. And then I want to show that the kernel of this map is the k fixed points, or is the g fixed points of the image, right? Well, but I need this to be surjective. Am I misunderstanding something here? Oh, sorry. Of course, I am being so stupid. Yes. The cohomology is defined as the cohomology of the g-fixed points of the complex. Of course. I'm just being insane. Okay. Yes, exactly. Yeah, okay. Then this is isomorphic to the h fixed points, right? Basically by the adjunction here, and then that is exactly the cohomology here. Okay. Nice. Okay. Well, proofs become so easy when you stop being silly. But I'm addicted to being silly, baby. This series will document my descent into madness. Well, I'd rather have my madness satisfy a descent property. If you're gonna have madness, you may as well have a whole stack of madness. Am I right, gang? Okay, let's see. It's about time to go. Well, this proof is long. We probably shouldn't start this proof. Is this all one proof? This seems like it's all one proof. Oh, no, it's not all one proof. Okay, maybe we can start reading this next part. Oh, it's just a remark anyways. Corollary. Oh, I see. Yeah, corollary, then a remark. If M is induced, then that is true. Because if it's induced... Oh, right. Because in this case, induced means induced from trivial. I see. Right. Interesting. This just has my head swimming with ideas for other things. I'm kind of excited to think about those, but I need to do my work. I need to work on the things I'm supposed to work on. Consider this exact sequence of G modules. If this holds, then the cohomology sequence becomes this, and right. So if HRJ is 0, right, it becomes this. We get those isomorphisms. Sure. For example, let M be a G module. Let M star be the induced module. Arad, this is the thing that you were pointing out the other day. There was this is the thing that you were pointing out the other day. Then M can be identified as a submodule of M star, consisting of those maps, and then we just define that to be the quotient, apply the above theorem, right, and we recover that the we can always determine the higher cohomology groups in this form. Yeah. Nice. More generally, wow, Milne's notes are so much better. More generally, if we have a long exact sequence, such that all of the JIs in the middle vanish, then we get HRGN to HR plus S, where that's the number of J's. Huh. I bet you it's like when you're reading a little book and there's a little foreshadowing and you're like, I bet the killer's gonna use that, you know. We're definitely gonna use this at some point to prove something cool, I'm sure. Right, and then break it up through the short exact sequences. Well, that's nice. That's just a nice little thing. Maybe a nice place to leave it. Well, let's read this last remark. And then we'll start tomorrow on the description by cochains. Actually, we'll probably skip through a bunch of this, because that's just so basic baby stuff. And we're big, strong, tough guys that know our math. Above the pay grade, sorry I missed your comment when you first dropped it there, extra. But if you're still here, happy studies to you too. Bro has lost it for real. Yeah, I never had it to begin with, Boris. Yeah. Pay attention. Never underestimate working with cochains. Yeah. Isn't there some quote from Marx? You know, you have nothing to, or no, who was it? Martin Luther King. You have nothing to lose but your cochains. I'm sorry. That's bad. I'm terrible. Anywho, what's this last remark trying to tell us? Say we have some exact sequence. It's infinite, and all of those higher things vanish. Then, this remark applies to every resolution of M by induced modules. Okay. Sure. Anyways, that's where we're going to leave it for today. You were thinking of a cocaine joke, but that's even worse. Am I going to get demonetized for saying that out loud, I wonder? I don't know. I keep clicking the box at the end when it's like, oh, did you talk about like foul language or something? Or, and then I say no, even though like something like that comes up on stream. But no one's taken my like $5 away for coffee. So, who knows? Okay. I'm going to see y'all later tomorrow. We'll prove some things about group cohomology. So, yeah, go compute some